Hello, my name is Mesut Durukal, and I'm very happy to be here and to be a part of UCAAT again this year. I'm a quality assurance engineer, and most of the other quality assurance engineers, I'm doing the test automation because test automation is inevitable nowadays, and we are mostly doing this considering that we are doing the continuous testing activities and we are trying to ensure the quality continuously in our products, and we are trying to avoid anything, any change or any update breaking anything, any functionality in our products. And we will talk about test automation. It is great. It has lots of different advantages and benefits. We will talk about them, but in the meantime, it has some challenges. We will talk about them as well. But only not problems, but some solutions and some proposals to get rid of these solutions. We will discuss one by one. So automation has lots of great advantages, like it is reducing the manual effort and it is reducing the execution durations, and some tasks can be done by the help of automation, which cannot be done manually, like performing lots of concurrent requests or doing the load testing. These kind of things can be done thanks to the test automation. But it is only the bright side of the test automation activities, but also there are some pitfalls and there are some tricky things that we have to get rid of and we have to cope with. There are some challenges we have to achieve. So let's discuss them. I try to do in a categorical approach. So we will discuss lots of different reasons stemming from different categories. So the first thing would be the some reasons or the challenges stemming from the product itself or the way of developing our products. Nowadays we are mostly doing agile practices, which means we are very open to updates and change. But of course it has some other side effects. Whenever we automate our test cases, then the automated test cases are running on pipelines. But if we apply any change, it is high possibility that it will affect the test cases as well. So we have to update the test cases accordingly. And if the behaviors are changing or updating by any customer request or any other product management decisions, then we have to change the expected behaviors which are asserted in our test cases. So this continuous maintenance of the test cases and the effort to update or keep the test cases up to date is very crucial, because even if they are not breaking, maybe if the behavior is already updated and there is another expected result, if our test cases is not updated, maybe we are not covering the new expectation and the new result which our customers are supposed to use. So keeping up to date is very important. This is one challenge. We have to put a continuous effort to maintain our test cases and align with the user behaviors or the product specifications. So the next thing would be some tricky behaviors, which are sometimes unstable. There may be some instabilities in our system, or the behavior itself may be tricky. Like if we are doing A and B testing activities, maybe we are deploying some different instances, or we are deploying some different versions on our instances. So which means when we are doing the testing activities, maybe we don't know in advance which version we will hit. So if we have multiple versions to do the A and B testing activities, then we have to somehow define our test approach, and we have to define already the expected behaviors or the expected results. Otherwise, if different versions are raising some different actual results, maybe some of our assertions will fail. This is one thing, the canary deployment activities or the A/B testing activities. But other than that, the behavior itself may be including some conditional behaviors, like depending on the users or testers or the end users data they provide to the system, then if they hit to some range, then it may trigger some conditional results. But if they hit to another range, then it may trigger some other conditions. So in this kind of cases, we may manage our test cases which are able to cope with these kind of conditional cases, corner cases. And eventually there may be some trick results, especially if we are doing the UI automation. Sometimes it is really tricky because sometimes after doing some operation the page is refreshed and we have to again locate all the elements, because after some operation, if the scripts in the page are running and triggering, then maybe some elements are detached from the page. So even if we locate them after some time or after some other operations, after some next test steps, we may have to locate them again and again. So these kind of challenging things may raise some instabilities and flakiness in our test cases. This is one more challenge that we may encounter in our activities. And the next thing is, if we have some hardware modules in our product or our in our system, then we may have some difficulties, because testing hardware is not easy all the time. For example, I was testing robots in my last project, so the expectation is they are moving around, and there are of course lots of different requirements, like if they detect or if they reveal that there is an obstacle in the path they are supposed to go, and then they have to go around the obstacle, so they have to find a new path, and it should be the minimum distance still. So these kind of things, how can we test? Of course, testing manually is easy. You can just operate the robots and you can place an obstacle, but if you are doing the test automation in software level, these kind of things are very tricky to handle. Of course, we can utilize simulations and test harness, but of course, generating all these signals and testing the integrations between all these hardware modules is not always easy. And even if we are doing the simulation, sometimes it is not covering the one-to-one physical conditions. So this is another tricky thing, and we may put a lot of effort and time to generate all these kind of test execution environments. So it is not easy, because another example in one of the projects that I was testing was, there was some IoT devices and they are onboarded if we plug in a token from a USB port. And in this case, if we are doing the test automation, then we have to manage all these kind of plug in and plug out from the USB port operations, and of course reading the file to verify the context of the token. These kind of things, especially in the operating system level, you have to do lots of different implementations. So it is not of course very straightforward, and it requires some management, some planning, and of course you have to allocate some resources to properly manage all these kind of activities. And apart from those, there may be some different testability issues which may be stemming from various reasons. We may have lots of different testability issues, which means we are somehow not able to test some use cases or some conditions to be covered by test cases. There may be lots of reasons, as I told. For example, if we have some dependencies, if there are lots of subsystems, and the subsystem that we are testing, the subsystem that is under test, is dependent to another module, and if some data between these two modules or the subsystems is somehow hidden or lost in communication, which means which are not publicly visible, then if the data shown on my subsystem is expected to have some other attributes, then maybe I will not be able to assert them, because they are already in the other dependent system. And if I don't have any public APIs or any other interfaces to check those data or the attributes, then I may have some difficulty to assert all my expected conditions or the results. So what we can do is, maybe at this point, working closely with the development teams is very important. We can plan and we can develop an approach, and we can try to improve the testability issues. For example, one initiative that we have performed in our team in my last project is sitting together to figure out all the testability issues, and I asked them to implement some other interfaces just for testing purposes. They will not be used in production environment, they will not be used by the end users, but just for the sake of testing and just for the sake of removing all the testability issues, we implemented some additional interfaces, and in this way I could verify the attributes or some other data which originally I was not able to check. And in this way we performed a collaboration between the development teams and the quality assurance teams, and we tried to get rid of all these kind of testability issues. One other challenge that we have to cope with is the AI components in our system or in our products, because nowadays AI is everywhere and we are mostly having some AI components in our systems and the products. And if we are developing these kind of modules and components, there are lots of different ways to evaluate the performance of our model or the algorithm. We can do this by our controlled data with some labeled data, but in terms of doing the functional testing, checking these kind of performance is not that much easy. If we suppose that we have a sorting algorithm in our system, then understanding if the sorting works well according to the dates, like if some elements are posted due to some different dates, and if we want to understand when we apply the sorting, they are really properly sorted from oldest to newest or the other way around, we can do that easily because we can just check the date attribute of each element, and then we can assert the expected results. But if we are supposed to check the sorting according to the relevance of the query, then it is not that much simple, because it is again be evaluated and measured while doing or developing the AI modules, but in terms of the functional testing, it is not that much easy. And AI modules is not the only thing which is not the non-functional aspects of the product, but also there are lots of different aspects of the quality, because apart from functionality, there is the usability of the product, accessibility, maintainability, lots of abilities there are, and including the performance and the resilience of the system, because the users' satisfaction highly depends on the usability and the resilience of the system, robustness of the system. So how we can assure these kind of other aspects of the quality? It is not that much simple, because we have to understand the impression on which the product gives to the customers or the end users. For example, there are lots of different negative test cases as well. If there is a mistake performed by the end user, then maybe we expect some pop-up windows notifying the users. We can easily check if the pop-up window is there or not, but how about the error message? If it makes sense, if it is very clear and understandable, and if it is well designed to make user aware of the mistake, then it is not that much easy to understand. And sometimes in these kind of cases, additionally, we should do the manual testing activities as well, because even if we do the automated test executions, sometimes we need additionally the manual testing to cover these kind of other aspects as well. And other than some issues or some challenges stemming from the product itself, or stemming from the way of our development practices, there are some other challenges stemming from the implementation itself. For example, even before starting the implementation, sometimes we have to set up the implementation or the execution environment, and sometimes it requires really too much effort and time, and we have to allocate some resources to perform these activities properly. For example, I will give you an example. In one of my projects, we were supposed to test a functionality in which some new accounts and new tenants were created, and after each creation operation, the tenant should be notified by an email. But of course, each tenant or each customer has individual email accounts. So normally what we should do is, in the real life, we should go to the email account, log in, and try to see if there's a new email sent by the system. But in automation, how we can do that? Because we cannot manage unlimited number of email accounts, physical accounts. It is not even possible to create that much unique email accounts. So what we should do is, what we should have done is, we have created an email relay, which was forwarding all the emails which were supposed to be sent to some email addresses in a specific pattern to one email address. In this way, we could do the verification of the email sendings or the notifications, but of course we had to do lots of different settings and configuration, and we have to learn the usage of the cloud platform services. So there was a learning curve as well. It was not that much easy. And one other thing after the setup is the implementation itself, because sometimes we have to apply different best coding practices, and especially the UI automation to make it really stable and robust, we have to apply different patterns, and we have to find a good way to locate the elements on the page. At this point, one other initiative that we have performed in our team was the stabilization of the locators. So we sat together with the development teams and we made an agreement. Like, instead of using the expats or some other complex and complicated locator selectors, we defined some test data IDs to each element. And even if the design of the web page has changed, this ID is remaining the same. So the tests were not broken, even if after some UI design changes. And after the tests are implemented, of course, they are executed on our pipelines automatically. But and we try to execute them before each merge to ensure that these changes or updates, these commits, are not breaking anything. But of course, if each time it is taking a lot of time, then it is not acceptable, right? Everyone will start to complain because they raise some PRs and MRs, but they have to wait for a very long time. So we try to reduce the execution duration as much as possible. So we have to develop lots of different ways. We can do parallelization, we can create lots of different virtual machines, but of course it will raise some extra cost as well. So it is a optimization problem. So we have to find the optimum way to manage both the execution durations and the cost of the usage of the system as well in the meantime. But what we can do is, at least we can get rid of the dummy weights if we have in our test automation framework, or if we have any redundant checks or codes which is not really needed to assert the expected result. We can get rid of these kind of issues in our test automation framework to optimize the test execution durations. And finally, the last ring of the whole chain is the maintenance, because we design test cases, we implement them, we execute them, and finally we have to continuously maintain them. And if there are any flaky tests which are sometimes failing and sometimes passing, then we have to cure them to get rid of the maintenance effort, to get rid of the failure analysis efforts. Because if they are stable and if they are reliable, we don't have to put too much extra effort, but otherwise we have to understand if they are really real bugs or false alarms. To get rid of these problems, we have to cure the flakiness in our system. But sometimes we try to cover all the issues stemming from the test cases. For example, if we are not waiting properly to test our asynchronous systems, then we are adding some extra poll mechanisms, and if the expected result is not there, we are trying to retry, right? But while doing these kind of covers, it is a little bit risky. Sometimes it is possible to overlook the real issues in the product. So we have to be very careful. In the meantime, we have to get rid of all the issues stemming from the product, from the test itself, but we have to be aware of the issues stemming from the product itself. And finally, last but not least, we can do the testing activities to find some issues and defects or some any other vulnerabilities, any other improvement rooms in the product. But it doesn't mean that if we are not finding any bug, then it doesn't mean that there is no bug, because we already know that there is no software bug-free software, and there would be already lots of different issues. But performing all the tests, executing all the tests, does not guarantee that there will be no issues in the product. This is not only related to the automation, but for the whole testing activities, this is one more challenge. We have to always try some other scenarios. We have to always try to improve our coverage, because otherwise we may miss some issues and the end users may encounter some problems in production. So just to wrap up, we went over lots of different challenges and tricky problems that we have to get rid of while doing the test automation. But of course, there are some solutions as well. Not only the problems, but also some proposals we discussed. Like, some problems are stemming from the product or our product development lifecycle or the workflows. But there are some different ways, especially working with other teams, because the strong communication channel is very important. Quality is not something which is performed individually, but it is a team effort, and it should be a holistic approach. So this was the summary of the challenges in automation practices, and there are some different ways to solve them. I hope it was insightful, and if you have any further questions, I would be more than happy to answer. And please do not hesitate to reach out to me from any communication channels. And thanks for listening, and enjoy the rest of the day.